Alright, this is part 1 of our video reviewing some basic properties of exponents. Well, n squared times n to the 5th is going to equal n to the 7th power. Obviously we were adding these exponents, but keep in mind what's going on behind the scenes as well. N squared is n times n. And meanwhile, n to the 5th power, that's 1, 2, 3, 4, 5. So if you multiply that all out, of course that is going to be 7 n's. That's why it's n to the 7th power. That will help you not make the mistake that students like to make on problem number 2, where they want to go, well, 2 times 2 is 4, so maybe they put 4 to the 5th power or something like that. Can't tell you how many times I've seen that. That is nonsense. This is going to be 2 to the 5th power. Alright? Just like when we had n squared and n to the 5th power, it was n to the 7th power. Alright? This base, and this base all stayed the same. This didn't change to something else. So similarly, this base and that base will all be the same. And again, what's really happening is 2 to the 2nd power is 2 times 2. And meanwhile, 2 to the 3rd power is 2 times 2 times 2. So if you put all that together, that is 2 times 2 times 2 times 2 times 2, 5 times. That's 2 to the 5th power. It's still 2's. They didn't become 4's. So that's the answer number 2. Okay, same thing here, only with an extra step to it. Notice we're not using a calculator, by the way. Do not touch a calculator during this process. If we have negative 2 squared and negative 2 to the 5th power, you multiply that together, that's going to give you negative 2 to the 7th power. Now we can't leave it like this with parentheses and such. If you take a negative number and raise it to an odd power, it's going to stay negative. So that's going to be negative 2 to the 7th power. Okay, just for comparison, let's say if we had negative 2 to the 8th power, because that's an even power, this is going to equal positive 2 to the 8th power. Alright, so if you do a negative number to an even power, it's going to become positive once you get rid of the parentheses. It's going to be the same thing as without the negative. But if you take a negative number to an odd power, then the negative will remain even without the parentheses. Anyway, so number 4. So this will clearly be z to the 13th power. You're right, we're adding those. Okay, now when you divide, the shortcut is to subtract, like 4 minus 3. So this is going to be r, just plain r. Now once again, I want you to understand what's going on behind the scenes. R to the 4th power is r times r times r times r. R to the 3rd power is r times r times r. So what's happening is these 3 r's are canceling out these 3 r's, and that leaves 1 r behind. That's why. Okay, thinking of it this way will help you later. So looking at number 6, using the shortcut of subtraction, we know this is going to be m to the 3rd power. But think of it as these 2 m's are canceling out 2 of these m's. Look at number 17. I'm sorry, 7, not 17. Some kids will go, oh, these 15's will cancel out, and the answer will be 4. Oh, that's a horrible, horrible idea. This is going to be 15 to the 3rd power. And again, the best way to think of it is canceling. 15 to the 4th power what's really going on is this is 15 times 15 times 15 times 15, 4 times. Meanwhile, in the denominator, we have 115. Well, the 15 in the denominator is canceling out one of the 15s in the numerator, and that leaves behind 3 15s. So that's why it's to the third power. If you wanted to use the shortcut of subtracting, you have to understand that this 15 in the denominator is the same as 15 to the 1 power. So you could do 4 minus 1, but the way I explained it first is the truest way of thinking of it. Now, thinking of it as canceling will help you understand what's going on with number 8. The thing that makes this slightly trickier is the fact that there are more x's in the denominator. So the truth is this is going to be 1 over x to the 8th power. A lot of students will just go, oh, 15 minus 7 is 8, and they'll just put x to the 8th power. They won't understand it's going to be 1 over x to the 8th power. Now, if you use the subtraction shortcut, 7 minus 15 is negative 8. So you would get x to the negative 8th power. That's true, but you're not allowed to leave negative exponents. So you still have to understand that negative x to the negative 8th power is the same thing as 1 over x to the 8th power. So you have to leave it in this form. And once again, what's really going on behind the scenes is, alright, x to the 7th power, there's your 7 x's. And here are 15 x's, x to the 15th power. Now, I conveniently changed colors here because 15, you could think of it as 7 and 8. Alright, so I colored the first 7 x's pink and the last 8 of them purple, but that's a total of 15. But of course I did it that way because the 7 x's in the numerator and the 7 x's in the denominator are going to cancel out. That's going to leave 8 x's. Okay, this is our x to the 8th power. But look, they are in the denominator. So we need this 1 in the numerator. And it makes sense why it's 1, because when you are canceling something out, like if you have 5 divided by 5, alright, anything divided by itself is 1. So when you're canceling out these x's, you're dividing x's by x's, alright? X divided by itself is 1. So it makes sense that this is going to be a 1. Okay, so when you have a power raised to a power, the shortcut is that you multiply these. So this is going to be 2 to the 12th power. Okay. Now looking at number 10, this is almost the same thing. So that's going to be x to the 30th power. Alright, you multiply these together. Power raised to a power, you multiply. Okay, now you have to be careful on this one because what about the 3 though? Like, yes, it's going to be z to the 4th power. Okay, but you also got this 3. So am I going to multiply and get 6, or am I going to do 3 squared and get 9? I'm going to do 3 squared and get 9 because what's happening is I've got this power, but that power is being applied to each of these things. So inside here I've got the 3 and I've got the z squared, right? Those are the two things I've got. Both of these things are being squared is what it is. So I've got 3 squared and I've got I've got z squared squared. So 3 squared is 9. But when you raise a power to power, you multiply. So this is 4 because it's 2 times 2. Alright, another way to think of it, as though you needed another way, anything squared is that thing times itself. So 3z squared is I'm sorry, 3z squared squared is 3z squared times 3z squared. So that makes it a little more obvious that is, of course, it'll be 3 times 3. So that'll be 9, not 6. I talk too much sometimes, and you stopped listening a while ago. So why do I bother? It's a teacher thing. So based on what we talked about a minute ago, negative 5 squared is going to be positive 25. Alright, I'm doing negative 5 squared. Okay, and if you square a negative number, it's a positive, because a negative times a negative is a positive. Anyway, of course, we will have the x squared as well. Okay, so that's number 12. Number 13. Whoa, anything to the 0 power is 1. Okay, just memorize that. Anything to the 0 power is 1. Doesn't matter what it is. So, yeah. Number 14, same thing. Anything to the 0 power is 1. Hello. So, okay, but look, can you see the difference between number 14 and number 15? See how this has parentheses around it. So all of this, because of the parentheses, this entire thing is being raised to the 0 power. Boom, 1. Now this one does not have parentheses. So this exponent of 0 does not include the negative 7. So y to the 0 power is 1. So then it's like I have negative 7 times 1, which is negative 7. Okay, but the bottom line is, without the parentheses, like this one has, that power of 0 only applies to the y, not the negative 7. Okay, order of operations, exponents before multiplication. Anyway, so there you go. So, okay, you have a fraction raised to a power. This is the same thing as having, let me put an intermediate step here. You see that we have x squared and we have this t, right? And then all of this is being raised to the third power. So just understand that it's happening to each one of these things separately. So x squared to the third power and t to the third power. We'll just raise the numerator and the denominator to the third power separately. So that is going to give us x to the 6th power over t to the 3rd power. Alright, power to power, you multiply. So that's number 16. Wazow. So number 13. Why did I say that? Number 17. So again, we're going to square each one of these 4 things. We're going to square the 5 and the m and the 3 and the z to the 3rd power. Okay, we're going to square all 4 of these parts. So 5 squared is 25. M squared is m squared. Okay, 3 squared is 9. And z to the 3rd squared. Okay, remember? Z to the 3rd power, well, that's hard to see. I said z to the 3rd power. If you then square it, power raised to a power, you multiply. So that is going to be z to the 6th power. Okay, looking at number 18. Same type of thing. I'm going to do the 4th power to each one of these 4 things. So 3 to the 4th power is 81. Okay, and then c to the 4th power is c to the 4th power. And 2 to the 4th power is 16. And y squared to the 4th power is y to the 8th power, okay, because 2 times 4. Now, you might have noticed that sometimes we leave numbers with the power. So here we have 2 to the 5th power, and I did not write this out. I think this is 32. I didn't put 32. I left it as 2 to the 5th power. And similarly over here I had negative 2 to the 7th power, and here I did 15 to the 3rd power. So why did I not put the actual number? And here I am putting the actual number. Well, the rule that we usually use is that if you have the 3rd power, if you're squaring something or doing the 3rd power, we go ahead and do it out. But if we have the 4th power or the 5th power or the 6th power or the 7th power, we can leave it if we want to. So I really could have left this as 3 to the 4th power, or like using that rule, I could have left it as 3 to the 4th power c over 2 to the 4th power y to the 8th power. Okay, this would have been acceptable. Just remember, you won't have a calculator. So if you don't know 3 to the 4th power in your head, then you're going to have to leave it. I knew it, so that's why I put it. Anyway, number 19. You see that negative power? If you have a negative exponent, that is going to drop you into the denominator. So like there's an invisible fraction bar right here. That negative exponent means that factor is going to move to the other side of the fraction. So it's going to come down here and become w to the positive 6th power. Now of course up here we'll need a 1 sort of as a placeholder. Okay, similarly, again, if you have a negative exponent, it means that that factor is on the wrong side of the fraction. It's got to be moved. So this 2 to the negative 3 power is going to have to move up. Alright, so that's going to move up and become 2 to the positive 3 power up there. Now, down here would be like a 1, I guess, but we don't need to leave something over 1. So it will be 2 to the 3rd power. Now, using the rule that I just mentioned a moment ago, if we're doing squared or 3rd power, we will go ahead and do it. So this will give us 8. 2 to the 3rd power is 8. Okay, so since we didn't actually wind up making a fraction, I won't put that. So that's number 20. How many of these are there, man? Okay, 21. So many ways to think about this. I'm going to think about it this way. When you have more than one factor and you are applying a power, what you're doing is you're doing the power to each one of those things. So this is like having 2 to the negative 3 power and m to the negative 3 power. Alright, so negative power drops you down. Alright, there's like an invisible fraction right here, and both of these things are going to have to drop underneath it. So I will have 2 to the 3rd power down below, and I will have m to the 3rd power. We will need a 1 sort of as this placeholder. Okay, and but 2 to the 3rd power is 8, and 3rd power we should always go ahead and do it. So this will be the answer to number 21. Okay, similarly, when you look at number 22, this will be like 3 to the negative 3 power and a to the negative 3 power. Okay, just like before, both of these are going to have to drop down. So this is going to give us 3 to the 3rd power, a to the 3rd power. We'll need this 1 sort of as a placeholder. 3 to the 3rd power is 27. Okay, if you're doing the second power or the third power, you should go ahead and do it. So that's number 22. Okay, now I see two factors that have negative powers. Alright, so I'm going to highlight them. This is on the wrong side of the fraction. It's going to have to drop down. And this is on the wrong side of the fraction. It's going to have to go up. So let me start by copying down the things that are not going to move. Okay, I feel like using a different color right now. Okay, so the b to the fourth power, that's not moving. Okay, it stayed right where it is. This 3, not moving. Alright, the 3 does not move with the a. Now, so these other two things are things that are moving. So a to the negative 2 power is going to drop down and become a squared. A to the negative 3 power is going to move up and become a to the third power. Okay, but then we're not done. Because we have a's in the numerator and denominator, we need to go ahead and simplify those. I mean, just like we would if we just had a to the third power over a squared by itself, like on earlier problems. This is just going to be a, right? So same thing here. These two a's are going to cancel out two of these a's and just leave a. So that's going to be a in the numerator, because that's where there's more. And then the rest of it. So I've still got the b to the fourth power, and I've still got the 3. Alright, but there's no more a squared here on the bottom. So this is the answer. Alright, looking at number 24. These are the factors that have negative power. So this one is going to have to drop down. Okay, and this one is going to have to go up. Alright, the other two are going to stay right where they are. So I will have I'll have this 28 and the 7. Alright, I will divide those in a moment. But the y moves up, so I will have my y to the third power in the numerator. The x is going to move down, so I'm going to have my x squared in the denominator. Now 7 goes evenly into 28. Alright, so technically you should think of it this way. You should think of it as dividing both of these by 7. Alright, we're dividing the numerator and denominator by 7. So, of course, 28 divided by 7 is 4. And then we've got our y to the third power. 7 divided by 7 is 1, which we don't need to write down. So that'll just be x squared. So this will be the answer to number 24. Okay, for number 25, this one has the negative exponent and will have to move upstairs. Alright, if I start off with a fraction, that m to the third power is not moving, so it's going to stay right there. But that n to the negative 2 power moved up and became n squared like that. Now there is nothing left in the denominator, and we're not going to put a 1 down here, alright, because that's the denominator, doesn't need it. So this is actually the final answer right here. Okay, number 26. We have a negative exponent on this factor, so that is going to have to move down. That's the only thing that's going to move though, okay, so alright, so for a moment I've got the 3 and the 15 and the y staying put. Alright, the x to the negative 4th power is going to drop down here. You know what, we like to, I started to put x to the 4th power like that, but it's traditional to do alphabetical order, so I'm going to switch those around. You know, no one's going to mark it wrong if you don't alphabetize it, but If you have OCD, go ahead and let this be part of your OCD. Okay, so there you have it. But this 3 divides evenly into 15. Again, you should really think of this as dividing both of these by 3, because that's what's happening, in fact. So 3 divided by 3 is 1, so there's that 1 up there. 15 divided by 3, of course, is 5. And then we have the rest of it, x to the 4th power y. So this is the final answer for number 26. Okay, so when you look at number 27, and what's happening is we have these separate little problems. So here I have 2 times 5, and that's going to be 10. Okay, and then I've got the x's. All right, so I've got x squared times x to the negative 2 power. Let me just write those right next to each other so it would be really clear. Like if I had x squared times x to the negative 2 power. Well, in fact, remember this. Like if I had, say if I had x squared times x to the 3rd power, what would that be? That would be x to the 5th power, right? Because we add these exponents, that's the shortcut. So what happens if I add these exponents though? Yeah, that's going to be 0. Now, what did we say would happen if we had anything raised to the 0 power? That's just going to be 1, right? Okay, so this is really like 10 times 1, all right, because of that. All right, do we really need that, or can we just erase it? Yeah, clearly we can just erase it. We'll do that on the next line. Anyway, so then we have the y's. So remember, if it helps you, think of this as y to the 1 power. Okay, so this will be y to the 4th power. Okay, y times y to the 3rd power is y to the 4th power. So that's why the final answer is 10y to the 4th power. Okay, we just don't need the 1 right there. Okay, and that brings us to number 28. Again, what's happening here is we have really 3 separate little things happening. All right, we have 2 to the negative 3 power. All right, and then we have r. Maybe I'll put them all in parentheses just for fun. Let me start over. Okay, so we have the 2, and then we have the r to the 4th power. I'm sorry, negative 4th power. And then we have the s squared. All right, we have these 3 factors, and all 3 of them are being raised to the negative 3 power. Okay, so we're going to do the negative 3 power here, here, and here. So what's going to happen? Well, for now, I'm just going to leave 2 to the negative 3 power just like that. But here, when you do a power raised to a power, you multiply. Well, negative 4 times negative 3 is positive 12. So this is going to be r to the positive 12 power. And then this, if we multiply, is negative 6. So that's going to be s to the negative 6 power. Now, don't forget, we have this invisible fraction going on here. And these 2 things that have negative exponents are on the wrong side of the fraction. So this is going to have to drop down. And this is going to also drop to the denominator. The r to the 12th is going to stay up where it is. So that's why the final answer is going to be r to the, maybe I'll squeeze it over here. I'll have r to the 12th power in the numerator. and then this is going to drop down and make 2 to the third power, and then this will drop down and make s to the sixth power. 2 to the third power is small enough that we should do it. Anytime if it's squared or cubed, you should go ahead and evaluate it. That's 8. So we will go ahead and put 8. So this will be your final answer for number 28. Alright, I hope that was helpful. I will see you on the next video.